Hello guys, welcome to Math Wizard with Distant Learning. Tonight, I just want to welcome you guys to a brand new year. And I hope you guys will be having a I really hope that the year will bring nothing but good news and less less bad news and more good news. Um for everything that we have been through in the last year, with the pandemic and all, I really hope that this year bring us something better, something good to look forward to. And as you guys are watching this video, and I hope each and every one of you will take the year and embrace it, and it brings you everything from prosperity to wealth to everything else. So as we said, from that being said, we are going to talk about something very different and very new. I don't know if I've talked about it or I've touched a little bit on it on previous videos, but let's go ahead and talk about the cofunctions, because and Trig, you are going to have to learn a lot of cofunction values or cofunction identity when dealing with these angles. So it's important that you actually have become very familiar with these identity. So tonight we are going to talk about the cofunction identity when it comes to the acute angle. So just let's go ahead and get back to business. So it's going to be the cofunction identities when it is the acute angle. Okay, the acute angle. So what is an acute angle? What is that? An acute angle is an angle that measures less than 90-degree angle. It's an angle that is less than 90-degree angle. It measures less than 90-degree angle. But however, when we talk about the cofunction identity, what does that entail? The cofunction identity. So let's just go ahead and write it down. Always make a habit to write things down, because the more that you write things down, the more you're going to remember them. It says for any acute angle, the cofunction value of complementary angles are equal. For any acute angle A, the cofunction value of the complementary angles with an S are equal. Complementary means something that adds, like complementary. Like, what is the complement? Just from the word, what does it mean? Complementary. It's going to be something that adds to the angle, that's going to give the size of a bigger angle. That's going to complement. When we talk about the complement, we talk about add-on. We see something that is going to add on to give us the value of the angle. That's the word complementary is. It's complementary. These are the complementary tickets that I'm giving you. Like, that meaning doesn't change. It's something that's going to add on, that's going to give you the value of the angle. For instance, so let's go ahead and dig and see. For instance, if we have sine A, it's going to give us the cosine 90-degree minus the angle. Second, if we have the secant A, it's going to give us the cosecant value 90-degree minus the angle. Third, if we have the tangent A, okay, it's going to give us the cotangent value 90-degree minus the angle. Okay, so let's move on into something that is much more like a little bit like, I want to give you something much more concrete that you're going to see exactly what I'm talking about. So let's see, for instance, if we have the sine of 55 degree. All right. So we're going to say it's going to be the cosine value 90 degree minus 55 degree, which is going to give us the cosine value of 35 degree. That's how we're going to say these are the cofunction, because 90 degree, remember the acute angle was something that is an angle that is less than 90 degree. So it's going to be 90 degree minus the angle. Okay, so let's move on to another concrete problem so we can see that. So let's say if we have the tangent of 72 degree, what would it be? It's going to be the cotangent. It's going to be 90 minus 90 degree minus 72 degree. And it's going to give us the cotangent value of 18 degree. This is how concrete this would be, very concrete. So we are learning about the cofunction identity of an acute angle. It says for any acute angle A, the cofunction value of complementary angles are equal. The word complementary means something that adds on to give on the value of the angle. It's always complementary, something that complements it, something that kind of add on to it. All right, so let me grab another paper. Okay, so this is quite simple. So I'm going to grab another paper where we're going to do a more complex problem that is going to involve fractions. So it seems, fraction is always something that scares a lot of people when it comes to fractions, or it's throw people's off, throw many of you like off when we have a problem that involves fraction. But I assure you that the steps are similar, they're the same. You just do it step by step by just simply following the rules. So let's go ahead and grab another piece of paper. So we're going to move on and see the more complex. Okay, so let me see. Let me go ahead and fix this, quite assure you that. So we are going to say, let me just go ahead and write down the problem. So let me move the camera a bit more. So it's going to be the cosine. Okay, it's going to be the cosine 3 theta over 5 plus 11 degree. It's going to equal to, I want you guys to be able to see it, sine seven theta over 10 plus 40 degree. Okay, put it at an angle so you guys can see it. All right, so let's move on to where we're going to just write it down. It's going to be the cosine 3 theta over 5 plus 11 degree. It's going to give us still the cosine. Remember, it was still the cosine. The cosine value of we're not going to do parentheses, but we're going to do this one instead of the parentheses, because this is going to be like, I'm going to call it the big parentheses. Okay, because we are going to do another parenthesis inside this parenthesis. It's going to be 90 degree minus, look at here, it's going to be minus parenthesis 7 theta over 10 plus 40 degree. All right, don't know if you're seeing it. Plus, so we are just doing, like, remember, like we have the cosine. So basically we are just following what would be the cosine. We have the 90 degree. It's going to be the 90 degree minus 7 theta over 10 plus 40 degree in parentheses that. Okay. So the next value we want to do is continue on. 7 theta over 5 plus 11 degree it's going to give us, what can we do here and here? We are going to use the distributive property where we are going to distribute both the 90 and the negative along the way. That's what we're going to do, is use the distributive property. And it's going to give us, when we take 90, this is negative, this is positive, so it's negative. So 90, and it's going to be 90 minus 50 degree. I mean, minus 40 degree, which give us 50 degree. All right. And we are going to definitely minus it by 7 theta over 10. Okay. So as we go along, we have, what we're going to do is, whatever we do, we're trying to get theta by itself on the equation. Okay. So we're going to move this fraction over here. So we're going to say, and we are going to move this one over there. All right. So we are going to say it's going to be, so this, we have a negative, we move it, we're going to have a positive. So we're going to have 7 theta or 3 theta. Let's say 3 theta. Let's move it to 3 theta over 5 plus 7 theta, okay, over 10. It's going to give us, we're going to move the 11 over here to 50, because at the end of the day, we want to get theta by itself. So 11, 50, take like 50 minus 11, it's going to be 39 degree. All right, 39. So in here, we have 2 fractions, but we cannot add these 2 fractions. And the reason why we cannot, we have 3 theta plus 7 theta, but we cannot add it because they don't have a common denominator. So we have to find the common denominator here for it. And we know the common denominator is going to be 10. For the common denominator is going to be 10. So this is going to be 6 theta. And then this is going to still remain 7 theta. And it's going to be 39 degree. Okay. So, and here, when we have to add them up. All right. We have to add them up. When we add 6 plus 7, it's going to give us 13 theta over 10. And it's going to give us 39 degree. All right. So the idea is to get theta on its own, okay? So in here, on both of the equation, we have to do something, which is going to be, we have to divide the fraction by the 39 degree. 13 over 10, that's a fraction. We have to divide it by 39 degree. But when we are dividing fraction, what do? We're going to flip and we are going to multiply. So we're going to say theta is going to be 39 degree times 10 over 13. Okay. Follow. Move this down. Improvising. And theta, it's going to be 30 degree. That is theta. So all we did is just basically we multiply and divide, flip. No, I mean, we basically move the fraction over here and we flipped it and we multiply. And when we do that, we have 30 degree. So theta is equivalent to 30 degree. So that's exactly how we would solve this one. So thank you for watching this video. Please don't forget to subscribe to the channel and like the video for more video. Thank you.